Hi, today we're going to talk about if at first you don't succeed, try again. This paper was presented at SOSP symposium, and it's about a tooling for detecting retry bugs in software system. So first let's talk about what is retry. So retry is a mechanism to hide the resilient failures inside the system due to some sort of software or hardware bugs. So how it goes. You're sending a request from application to the server. If it doesn't respond, you're trying a request and getting a response back. But this approach brings a lot of potential problems. As such, for example, in one of the top applications made in Java, they were reported a lot of bugs till now. And this during the writing of this paper, they released even more bugs hidden in the system, but not tested properly. So the problems introduced by retries could be divided into three categories. If retry should perform, when and how. So if retry should be performed could be the case when recoverable error is not retried when it should. For example, in this case, in Kafka, they found that during the unknown topic or partition error, they were not retrying why they should, and it was resolved in this issue. In this case, non-recoverable error was retried in Hadoop system because the exception that causing access control was hidden inside the Hadoop exception, and it could not be identified right away. So they saw it during the issue report. It's another case of how if retry could happen. Another one, if the retry shouldn't be performed at all. So the cancel task was retried because there was no any way to identify if it was retried or not beforehand. But after reporting this issue, they fix it. It's just like one line of code. But still, to catch this error, it's very hard at the beginning. It takes a lot of time. So when retry should be executed also is crucial. So for example, in this HBase issue, they found that the retries were retrying an instant after failing, and they didn't have any backup to prevent it from overflowing the system. In this case, if retry at max attempts was set to the negative number, the retry count get will never reach this criteria, and it will not stop retrying. It was just going and going without stop. Another case of how to execute retry was found in a Spark. They had this so-called zombie stage sometimes, and while it was not be able to execute, they were retrying the system. At that time, they were changing the state. But when this zombie came back eventually, it altered the state again, causing negative number of running task counter. It was causing to stop and fail a lot of jobs. So how usually we are trying to find this retry errors? Usually done by unit testing, but since unit testing check only one small portion of the code, it's really hard to identify when you have big cascade of errors and exception. It's hard to miss one or several even of them. So they introduced the solution Wasabi. It's a way to identify these errors. It consists of several steps, one of which is static analysis using CodeQL and GPT-4 language LLM. With this static analysis phase, they identify the location of possible retries. After that, the fault injection model inserts a fault alerts inside the system, and using already pre-existing unit cases, they testing the code again and again to see if the retries doing the job properly. Also, this all covered and accompanied with test protocol phases that help the system to check such things like missing cap, missing delay, and different type of exception thrown during the system. So a static analysis routine that processes program source code and reports where the time may happen. It works like this. So they taking the source code, sending it to CodeQL. CodeQL generates nodes of code console flow execution, and if they found any loop in the system, they mark it possibly as a retry location. But since sometimes it could be just because of input changed, they add additional check by checking the naming inside this calling functions. They checking is there any name like retry or retries to understand if it's really about retry or it's just some another loop in the system that could possibly happen. But they're still not able to find all of them. That's why it could cause a false positive result. For ChatGPT, they're sending source code with these questions, basically finding where retry could happen. Is it retriable? Is it about retry? Is there a sleep inside this retry? Is there a cap or time limit on it? Do any retry contain methods either like compare and send? After gathering this data, they still rechecking it with CodeQL workload since the retrying problem that's written in the code could be code from some different file. So they still have to run through CodeQL to identify the real starting point. After this model is complete, they returning the retry allocation triplets, the coordinator method, retry method, and retry trigger exception. Taking these three parameters, they wrote a function on collide. So they passing a callee code and exception to the function and trying to simulate a triggered exception by it. How it works. So basically, they taking the unit tests that already exist, and to call an error, they inserting a trigger. Once this exception is thrown, the unit test to not for unit test to catch it, they made this handler. After some number of retries, key that could be changed from 1 to 100. For 1 is just simple retry check, and 100 to check if the cap is missed or the way are missed. They inserting the logs and sending back the retry. Is it retry bug? Is a retry bug or not? They're using aspect J instrumentation, the handler function, to create this kind of handler. So with the test protocols, it simply checks if the unit, there are three of them, missing cap, the test, if the unit test run for more than 50 minutes or have more than 100 retries, it means that the cap for the try is missing. So it's already a bug. For the missing delay, they checking the logs written in here and checks the timestamps between them. Is there no pause between the two requests and no any wait between requests? It means that they're missing the delay between the requests, and it also a possible problem. So, and for different exception code, it checks if the exception thrown is different from injected with Wasabi system. Also, some different types of problem could be identified using GPT-4 detector by just prompting the possible errors. By this, they find mostly the WAM bugs. But as you can see, there's a lot of false positive results in it. So out of 139 errors found in the system, 60 of them were false positive. And by unit testing, they found 63 bugs, which of them, like 21, was false positive. So I'm not sure how productive it is. In common among 8 systems they tested, they found 205 retry oops and 140 retry oops with 84 other retries structured by GPT-4. Out of them, around 100 of them were retry bugs found at different locations. I think so. About this paper.